Okay, so we are now going to explain what we call synapses and lead it to what we call the neurotransmitters. What we're going to do here is explain how the neurons actually communicate with each other. So, like mentioned before, they are almost like little messengers that communicate with each other. And we're going to explain how that actually happens. We're going to start off with something called a synapse. What that basically means, it's a junction between the neurons, releasing chemicals that either excite or inhibit the adjacent neuron. In other words, the synapse is a microscopic gap in between the neurons. It turns out they don't physically touch each other. There's this little gap in between in which chemicals are secreted to allow them to communicate. At the end of the axon, remember the axon's kind of like the tail of the neuron, there is these branch tips called terminal buttons. Now notice this word is spelled kind of funny, terminal button, because it does come from the French language. Terminal meaning at the end, and buttons, of course, meaning round. So these are round bulges at the end of the axon, which, as it turns out, contains chemicals. Just to kind of show you what we mean, so here we have two neurons in a chain. Remember, neurons are lined up in these interrelated networks. And if we trace the axon down here, we see the terminal buttons, so these three bulges here. And if we magnify that, so this is the synapse right here. So once again, a gap in between. And in this terminal button, there are these little pockets called synaptic vesicles. Those contain chemicals which are released at any given time to allow the neurons to communicate with each other. Those chemicals are called neurotransmitters. You can think of these as the brain's chemicals. You may hear someone say that they have a chemical imbalance in their brain, and this is kind of what we're referring to. So neurotransmitters are these chemicals that are stored in the neuron, remember specifically the terminal buttons, that activate receptors of other neurons. So it turns out there are many different types of neurotransmitters, and each of them have different functions. So what generally happens is when these neurotransmitters are secreted here into the synapse, we will find that there's little receptor sites located on the dendrite of the next neuron. And these chemicals will almost pass across and fit in a lock and key fashion. So those receptor sites are shaped for those chemicals. Once the chemicals attach, they create a reaction which allows the neuron to transmit its message. Now, several things can happen once these neurotransmitters are secreted into the synapse. They can bounce around for a while. They can attach. Sometimes they are reabsorbed into the previous neuron, and we call that reuptake. So this is just sort of explaining the process of how the first neuron reabsorbs the neurotransmitters for future use. So they can be metabolized, they can continue to bounce around, continuing to influence things like mood or behavior. They can attach. So the point is that many different things can actually happen once those guys are secreted. Well, now we've reached a really critical point to explain how these neurotransmitters are important and why we're even talking about them to begin with. We know that neurons are connected, or the levels of neurons, neurotransmitters, are connected to psychological problems. For example, we have a neurotransmitter called serotonin, and of course depression. So depression, as most people know, feeling sad, possibly suicidal, a very depressed state of mind. And we've discovered that serotonin is related to feelings of depression. In other words, the levels of serotonin seem to be important to our mood. What we've discovered by studying the nervous system of individuals with depression is that they may have low levels of serotonin. What we think is happening is that serotonin is secreted into the synapse, but for whatever reason, it is being reabsorbed too quickly through reuptake. So of course, the common medication given for depression is Prozac. What Prozac basically does is it prevents the reuptake of serotonin. So just to kind of show you what I mean here, we'll go back to the diagram. And we said that the neurotransmitters are secreted into the synapse. So what Prozac does is it creates almost like a barrier to prevent that serotonin from being reabsorbed too quickly, and thus serotonin neurotransmitters would remain in the synapse longer, which would help to boost their mood. In fact, I've worked with individuals who take Prozac, and unfortunately these people have had very troubling backgrounds, including their childhood abuse, drug abuse, just all kinds of problems. And I remember some of the clients saying that whenever they're on Prozac, they can't cry. They're unable to physically cry when they take Prozac because it's preventing the levels of these chemicals. In other words, it's keeping serotonin here in the synapse longer. Okay, so that's going to conclude our short lecture on neurotransmitters in the synapse. Keep in mind there are many neurotransmitters that do many different things. And I also want to say in conclusion that you have to be careful with these guys because we cannot always imply causation between psychological disorders and levels of these chemicals. In other words, they're a piece of the puzzle, but like everything in psychology, there are many moving parts that we would need to consider. So please don't get locked into the mentality that neurotransmitters or the levels of these chemicals explain everything when it comes to human behavior. Once again, humans are complex and we're influenced by many different things, and this is just an example of one of those things.